All right, now looking at the College Algebra Exam 1, Part 3, we're going to start with number 28 here, Part A. So Part A wants us to solve the following equation in quadratic form and making an appropriate substitution. So originally we have 2 plus 3 over x squared minus 2 plus 3 over x is equal to 12. So first off, I'm going to move this 12 over so we can kind of get it in a more quadratic way that we're used to seeing. Squared minus 2 plus 3 over x, and then minus 12 is equal to 0. Now this question really wants us to make a substitution. So we see that we have a 2 plus 3 over x squared and 2 plus 3 over x. That kind of makes us want to think that we want to set 2 plus 3 over x equal to something. I'm going to say it's going to be equal to u in this case. So now we're going to have a u squared minus u minus 12 is equal to 0, right? So now that puts us back in our normal quadratic form that we need. So now we want to solve this. So we want to know what two numbers are going to multiply to give us negative 12 and add up to give us negative 1, essentially. There's a 1 right there implied. So two numbers that multiply give us 12 are going to be 6 and 2. Those in no way are going to add up to give us a 1. What about 4 and 3? So we could do u minus and then u plus, right? So we're going to know that it's going to be u minus 4 because we need to keep it a negative, and u plus 3. If the negative times positive is going to give us this negative 12. And this being negative right here is what's going to give us a little hint that we need to, our larger number needs to be a minus. So now we know that u minus 4 is equal to 0 and u plus 3 is equal to 0. So now we want to know what u is. So we're going to add 4 on both sides. So we have u is equal to 4 and subtract 3 on both sides. So u is equal to negative 3. So we also know that u is equal to 2 plus 3 over x is equal to 4, and 2 plus 3 over x is equal to negative 3. Solving each one, I'm going to start with the left side. We're going to have subtract 2 on both sides, so 3 over x is equal to 2. Multiply our x over, so 3 is equal to 2x. Then now what I'm going to do is divide both sides by 2. So x is equal to 3/2. And now to move on to our other equation, I'm going to subtract 2 on both sides. 3 over x is equal to negative 5. Multiply our x over, so we'll have 3 is equal to negative 5x. And then now divide both sides by negative 5, so x is equal to negative 3/5. So we're going to have x is equal to negative 3/5 and 3/2. Now looking at part B, we're given t to the 2/5 minus 2t to the 1/5 is equal to 24. It's a really bad 5. So I'm going to get it in more of a quadratic form. So t to 2/5 minus 2t to the 1/5 is minus 25. So I'm going to subtract 25 on both sides. 0. So now, like this question asks, we want to solve with a substitution. So what can we make our u equal to in this case? Well, I would say t to the 1/5. It's going to take care of this term right here. And if we separate this one out, t to the 2/5, if we write it in the form t to the 1/5 to the power of 2, it's going to give us our squared still and give us in a quadratic equation form, or quadratic form. So we're going to have u squared minus 2u minus 25 is equal to 0. So now we got to think about what two numbers, oh, not 25, this has been 24 this whole time. 24 here, so 24, 24. This one's also going to be 24. That makes it a little bit easier. So we got to think about what two numbers are going to multiply to give us negative 24 and add up to give us negative 2. So now let's just look at what two numbers can multiply to give us 24. We got 12 and 2, 24 and 1. Both those don't seem very viable. 6 and 4, those seem pretty good. So we have u, so we're going to do u minus 6 and u plus 4, because since this value right here is negative, we want our larger one to be the u minus, right? So we take negative 6 and add 4, we're going to get that negative 2, and we multiply them together, we're going to get negative 24. So now we say u minus 6 is equal to 0, and u plus 4 is equal to 0. Solving for u of each of them, we're going to add 6 on both sides. So we're going to have u is equal to 6, and we're going to subtract 4 on both sides. So u is equal to negative 4. But we also know that u, like we said, was t to the 1/5 is equal to 6, and then t to the 1/5 is equal to negative 4. So now to find what t is going to be equal to, we want to take both sides to the power of 5 to get rid of the 1/5. So t is going to be equal to 6 to the power of 5 is going to be 6 to the power of 5 is 7,776, and negative 4 to the 5. Since the negative power, it's going to stay negative because we're going to have a negative. We're going to have 4 negatives, which are going to end up being positive, and then one more negative left over. Odd, any of the power of an odd number is always going to be, it's going to stay negative. So negative 4 to the power of 5 is going to give us negative 1,024.
Solve the equation for the indicated variable. V is equal to 4/3 pi r cubed. So multiply both sides by 3/4 equals pi r cubed. Divide both sides by pi r cubed. R is equal to the third root of 3/4 times 1 over pi times b. Solve the following linear inequalities. Graph the solution and write the solution in interval notation. 6 minus 5x greater than or equal to 24. Add 6 to both sides, and then we'll divide by negative 5. And then we need to flip the sign because we divide by a negative or multiplied by a negative number. So x is less than or equal to negative 6. So if we have a nice number line, and I will call that 0. Over here's our negative 6, and we're bracketed, continuing on that way. Okay. Oop. 8 is greater than or equal to negative 5 halves c minus 2. So we'll add 2 to both sides. C, and then we're going to multiply by 2/5 on, or negative 2/5 on each side, and remember to switch the sign. So we'll get negative 4 less than or equal to c. So then we can have our nice number line. Again, we'll say something like 0 here, negative 4, and then our solution space is that way. Given A is a set containing 2, 4, 6, 8, and 10, and B is a set containing 0, 3, 6, 9, find A union B. So it's going to be 0, 2, 3, 4, 6, 6 just once, even though it's repeated in both of them. 8, 9, and 10. And then A intersect B, the only time that they contain both the same is 6. Solve the following compound inequalities, graph the solution, and write the solution in interval notation. So we have 3 x minus 2 plus 2 less than or equal to x minus 8, or 4x plus 1 plus 2 greater than negative 2x plus 4. So we'll solve the left-hand side and then the right-hand side. So start combining like terms by subtracting or adding to either side. 2x less than or equal to negative 4, x less than or equal to negative 2. Now we solve for the right side because we're doing an OR. So we'll get 4x plus 4 plus 2 greater than negative 2x plus 4. Again, combine like terms, and we'll get 6x greater than negative 2, x greater than negative 1/3. And then to graph it on the number line, dealing with OR functions. So for negative 2 here, negative 1/3, parentheses, bracket. So we are less than or greater than. So that'd be the graph of it, and then interval notation. Go from negative infinity to negative 2 inclusive, union negative 1/3 to positive infinity. Now we have 3x plus 5 less than 17. And 5x plus 2 greater than negative 8. So we'll do the same thing, solve for the left and then the right, and then consider the and. So 3x less than 12, x less than positive 4. This one we'll get 5x greater than or equal to negative 10, x greater than or equal to negative 2. So the number line, and this is going to be a lot, or 4 come here, be our negative 2, need to be greater than negative 2 and less than 4. So that's our solution space. And then in interval notation, that would be from negative 2 to positive 4.
Okay, now looking at question 33 here, we want to solve the double inequality, 3-part compound inequality. For negative 2 is less than or equal to negative 2x plus 1 over 3, which is less than or equal to 4. We want to graph the solution and write the solution in interval notation. So the first thing I want to do is get rid of this fraction by multiplying everything by 3. So we're going to have negative 6 is less than or equal to 2x, negative 2x plus 1, less than or equal to 24. All right. Now I want to start solving. So first thing we're going to do is subtract 1 from each part. So this is going to be negative 7, less than or equal to negative 2x, which is less than or equal to 23, right? So now what we want to do is divide everything by -2. But since we're dividing by a negative, we're going to also flip our inequality signs. So -7/2, or -7 divided by -2 is going to be left with 7/2, which is greater than or equal to x, which is greater than or equal to -23/2. So now to graph this, we're going to draw our line here. We're going to have -23/2, and we're going to go to 7/2. We're going to fill it in here, and it's going to go everywhere in between those 2 points. All right, so to write this interval notation, we're going to have -23/2. We're going to 7/2. Both the brackets, because they're both included, because it's the equal and the inequality sign. Okay, so looking at question 34 here. The months of June, July, August, and September are the wettest months in Miami, Florida, averaging 7.83 inches per month. If Miami gets 8.54 inches in June, 5.79 inches in July, and 8.63 inches in August, how much rain is needed in September to exceed the monthly average for those months? Exceed. So answer with a complete sentence. So one thing we want to do is think about what gives us an average. What happens when we add up all our numbers and then divide by however many we had, right? So we have June, July, August, and September. So that's 4 months. So we're going to divide by 4. And then in our numerator, we're going to have the rain for each month. So in June, we had 8.54. Then we had plus 5.79 in July, plus 8.63 in August, and we don't know what it is in September, so right now I'm going to call it X, right? And now we want to know how much it's going to take to exceed the monthly average, or how much we're going to need in September to exceed the monthly average for those 4 months. So we want to be greater than our monthly average of 7.83. So now we have this, and now we just want to solve it. First thing I'm going to do is simplify our numerator with that 8.54 plus 5.79 plus 8.63 to give us 22.96 plus x over 4 is going to be greater than our 7.83. Now what we're going to do is multiply 4 to get rid of our fraction on both sides. So we're going to be left with 22.96 plus x is greater than 7.83 times 4, which is 31.32. Now to find what x is, we're just going to subtract 22.96 on both sides. And that should give us that x should be greater than 8.36 inches of rainfall. So in our sentence, we should say that there needs to be more than 8 point. More than 8.36 inches of rain in September. To exceed the average. Okay, now looking at question 35A. Solve the following absolute value equation. So we have 2 absolute value of 3x plus 5. Close the absolute value minus 4 is equal to 12. First thing I'm going to do is just get all like terms together, make sure we just have an absolute value on one side. So I'm going to add 4 first. So we're going to have 2 times the absolute value of 3x plus 5 is equal to 16. Now I'm going to divide both sides by 2. and we're going to be left with the absolute value of 3x plus 5 is equal to 8. So now we know everything inside this absolute value can be either negative 8 or positive 8. So what we can say is 3x plus 5 is equal to 8, and 3x plus 5 could be equal to negative 8. So we need to solve for each of these and find out what our x's are for each of them. So minus 5, so we have 3x is equal to 3. Divide both sides by 3. So we know 1x is going to be equal to 1. And then over onto our other one, we're going to subtract by 5 now over here. We're going to have 3x is equal to negative 8 minus 5, which should be negative 13. Divide both sides by 3. So another one's going to be x is equal to negative 13 over 3. Now looking at part B, we have the absolute value of x plus 4 minus the absolute value of x minus 7 is equal to 0. First thing I'm going to do is add that x minus 7 on both sides. Not in parentheses, it's a absolute value bar. So the absolute value of x plus 4 is equal to the absolute value of x minus 7. So we know that our solution is going to be positive or negative values of what's inside of here. So one of them is going to be x plus 4 is equal to x minus 7. Another one, how we can write it, is make one of them negative. So we're going to say x plus 4 is equal to negative x minus 7. So solving our left-hand one first, we have x plus 4 is equal to x minus 7, which if we start doing this one, we're going to have negative x, those are going to go to 0. We're going to have 4 is equal to negative 7, which isn't a solution. So this does mean that our equation is only going to have one solution. So over here, we're going to have x plus 4. I'm going to distribute out that negative to negative x plus 7. Add the x. So we're going to have 2x plus 4 is equal to 7. Subtract 4 on both sides. So 2x is going to be equal to 3. Divide both sides by 2. So our solution for this equation is going to be x is equal to 3/2. One way to verify this is by plugging both values into your graphing calculator, into your y is equal to graph, see at what point they cross at. Always show your work though. Moving on to question 36, we want to solve the following absolute value inequalities, graph the solutions, and write the solution in interval notation. Starting with a here, we have 3 times the absolute value of 5 minus x, close that absolute value, plus 2, less than or equal to 14. One thing I'm going to do is get to where just the absolute values on one side by itself first. Subtract 2, both sides. So we're going to be left with 3 times absolute value of 5 minus x is less than or equal to 12. Now dividing both sides by 3 to get the absolute value function by itself. We're going to have 5 minus x is less than or equal to 4. Right? Now using what we know about absolute values, we can separate this into minus 4 is less than or equal to 5 minus x, which is less than or equal to 4. Right? Now solving this, I'm going to subtract both sides by 5 first, or all sides by 5. So we're going to have negative 9 less than or equal to negative x, which is less than or equal to negative 1. So now we want to know what x is, so we're going to divide by a negative 1. And since we're dividing by a negative, our inequality signs are going to flip. So we're going to have 9 is greater than or equal to x, which is greater than or equal to 1. So rewriting this in the typical way, we have 1 less than or equal to x, which is less than or equal to 9. And now we need to graph this solution. So draw our line here. We have 1 here, 9 here. Since we have the equal to, we're going to fill it in here and here. And it's going to be everything in between these two. And then writing an interval notation, it's going to be from 1 to 9, everything being included. Okay, looking at part B here, we have 4 times the absolute value of x plus 2 minus 10, which is greater than or equal to negative 6. One thing we want to do is get all our absolute values on one side by themselves. So we're going to add 10 on both sides, plus 10. So 4 times the absolute value of x plus 2, which is greater than or equal to negative 6 plus 10. It's going to leave us with 4. Dividing both sides by 4 now. We're going to have x plus 2 is greater than or equal to 1. And for this one, we're going to have to break it up into x plus 2 is greater than or equal to 1. And then also, x plus 2 is less than or equal to negative 1. So we're going to solve each of these. I'm going to move this one over real quick. Alright. So, subtracting 2 on both sides for this one, we're going to have x is greater than or equal to negative 1. Subtracting 2 on this one, we're going to have x is less than or equal to negative 3. So drawing this on our number line, or graphically, we're going to have negative 3, negative 1. So let's start with negative 3. It's going to happen when it's less than negative 3 and equal to. It's going to be anything this way. And then for negative 1, equal to or greater, it's going to be this way. So unlike our previous examples, we're going to have nothing that exists in between those two numbers. And to write this in interval notation, we're going to have negative infinity to negative 3, bracket because we're including the negative 3. Then our union, bracket because we're including our negative 1, and then all the way to infinity. All right, looking at number 37, part A, we have absolute value of x minus 5 is less than negative 3. So one thing, since it's a special case, we want to solve the following absolute values in quantitative special case solution sets. So for this one, our solution is actually just going to be an empty bracket because nothing that we plug in for x is going to give us less than the value of negative 3. Doesn't matter what we plug in here, it's always going to be a positive value, so it's always going to be positive, which a positive value is always going to be greater than negative 3. So for that, we're going to have an empty set. Or another way we can say that is there's no solution. Now looking at part B, we have the absolute value of x minus 2 is greater than negative 4. And kind of like the opposite of our first one, no matter what value we plug in here, it's going to be positive, which is always going to be greater than our negative 4 value. So in this case, we're going to have all real solutions, or our solution that's going to be from negative infinity to positive infinity. Okay, now looking at part C here, we have the absolute value of x plus 1 is less than or equal to 0. So in this case, nothing can ever be less than 0 because that means it's a negative value. So we can consider this as absolute value of x plus 1 is equal to 0, right? Which another way we can say that is no matter what, it's going to give us a positive value. So we can say x plus 1 is equal to 0. So in this case, this happens when x is equal to negative 1. Okay, looking at part D here. Part D, we have the absolute value of x plus 1 is greater than 0. So no matter what we plug in for x, it can never be less than 0, right? Because it's always going to have that absolute value. So essentially what we need to do is find out what value of x is going to give us 0, because that's going to make it equal to 0, so that's not gonna work with our equation. So let's just set x plus 1 equal to 0. So when x is equal to negative 1, we have no solution at that point. Not a solution. So essentially what this is saying is that everything other than negative 1 is a solution. So we're gonna say from negative infinity to negative 1. And then we're going to union from negative 1 to infinity. Okay, now looking at question 38, our last question for this exam review. A box of cereal is labeled to contain 16 ounces. A consumer group takes a sample of 50 boxes and measures the contents of each box. The individual contents of each box differ slightly from 16 ounces, but no more than 0.5 ounces. Right? So this means that our box could be 0.5 ounces over what it's supposed to be, or it could be 0.5 below. So what we can do here is write an equation. So we want to use our absolute values and say, okay, pen's working now, x minus 16, absolute values, is going to be less than or equal to 0.5. This indicates that we could be 0.5 above our 16 ounces or below our 16 ounces. That's going to be our part A right here. And then part B wants us to solve the inequality and interpret the answer. So I've kind of been interpreting as we go, but this is also meaning that we can have negative 0.5 less than or equal to x minus 16, which is less than or equal to 0.5. What we're going to do is add 16 to both sides. So 15.5 less than or equal to x, which is less than or equal to 16.5. And interpreting this like what I've been saying, that our cereal box could contain 0.5 or 0.5 above or 0.5 below the labeled 16 ounces. Below the labeled 16 ounces. That's going to be all for this exam review 1. Good luck on your exam, everybody.